So smart grid is nothing but a bidirectional flow of the electricity. So therefore, here also we required a bidirectional communication, both the way, not bidirectional. Is it? Okay. Does the previous resource persons come particularly discuss some heights? Okay. They have any discussion on MATLAB or any other software which are used? Yeah. Okay. Mm, mm. Okay. Okay. Good. Good. Yeah. Okay. So there was no any kind of software. So good. We have good discussions to follow on MATLAB. I have three, four examples for grid integration. So how to simulate, how to set the data, so that we can discuss in our session. Yes. Yeah. Good afternoon, Geeta
Good
madam.
afternoon, everyone.
Yes, yes.
Am I audible to everyone?
Yeah, Priyanka madam,
Okay.
you are very clearly
Uh,
audible. You can go
Firstly,
ahead.
I welcome all the participants and I warmly welcome today's our resource person, Dr. Vilas Bugade, sir. Welcome, sir. Firstly, I introduce him
Thank you.
shortly. Sir has completed ME in Power System, a PhD in Electrical Engineering. He is a scholar and researcher specialization in smart power system and solar energy with solid foundation in smart grid acquired during his research studies. Sir embarked on a journey of academic excellence in master's degree. Dr. Bugade has focused on electrical machine and power generation techniques to enhance energy system. His research center on solar PV system and power system for distributed generation. Sir is also a NSS program officer and received Samaj Sevak Award from PCMC and Kolhapur Mitra Mandal. Warmly welcome, sir. I welcome on behalf of our institute, Dr. Bapuji Sawanke Institute of Engineering and Technology. Sir, I request you please start your session, sir.
Yes, yes. Thank you. Thank you for my brief introductions. Basically, I also want to thanks to the management of Sri Swami Vivekananda Shikshan Sanstha, Kolhapur, Honorable Sri Abhay Kumar Solanki sir, who is a chairman of this particularly Shikshan Sanstha. Honorable Principal so Shubhangi Gawande Madam, who is a secretary for this Shikshan Sanstha, and young and dynamic CEO. I met once to him, Honorable Sri Kaustubh Gawande sir, and basically convener for this FDP is well-known personalities in Western Maharashtra. Is Dr. Viren Birdi sir, who is working as a director over there. Also, your principal, Dr. Suhas Sapate sir. And chief coordinator of this workshop is Praveen Bhatt sir, who is heading electrical engineering department for particularly this college. And there was a coordinator and co-coordinators, Gosavi sir and Mulani sir. So thank you for creating this platform for the faculty for understanding what requires in electrical engineering is the next. And your theme is very nice. I want to appreciate that. What was your theme? Is a yes? Anyone? Any participant? No, no. So, Kosai, so don't tell you. Participant. What was the theme basically? Yeah, any participant can unmute and tell us. Yes. What was it? Save the polar, go solar. Yeah, it's a polar means what? It's a universe. Okay, that what we have studied particularly in the complex number, real and imaginary part. Okay, so in that we used to convert from the rectangular to polar and polar to rectangular. I think this all of you remember is not. Yes or no? Hello. Yeah, yeah. I think participants are why they keeping mum. Okay, let me share my PPT. Okay, so I'll take the some 1 minute for that. Yeah, yeah. The screen is visible. Yes, sir. Hello. Yeah, yeah. Thank you, thank you. So the topic for today's discussion for myself is using MATLAB for solar PV performance analysis. I'm presently working as a associate professor in electrical engineering department at Marathwada Mitra Mandal's College of Engineering. In short, it's called as MMCOE, Nagar, Pune. This was my email ID for further communication. Should I go for a slide mode or like this? It's visible to all of you? Yeah, thank you, sir. Okay, so this was the today's outline for the my presentation. We are going to cover as per the content of the FDP, where we are going to discuss about solar cell, then some performance curves of the solar cell based on the input. What we can say in case of electrical or in a mechanical, we used to calculate the efficiency and what we required parameter is input and output. So we used to take a ratio of that is output divided by the input and then efficiency. So how that particularly individual solar cell or solar photovoltaic is going to give its performance. So this we are going to discuss in our second one. Yeah, important is our electrical, and maybe some mechanical faculty was there, those were joined. Okay, so when I'm going to say the electrical, it doesn't mean that I'm going to particularly focusing on the electrical only. It's again mechanical and electrical assistant concerns because whenever we talk about the electrical machines, okay, then when we say the motor, what we used to say, it converts the electrical energy into the mechanical energy. And when we when we see for the generator, okay, which is generating the electricity, what we used to say, it converts the mechanical energy into the electrical energy. So vice versa things are happening with these two machines, okay, and that's why the we need to say the particularly is electrical and mechanical are working together. It may be some faculty of the computer science and it may be some faculty of the from the electronics and telecommunication. They have the now they are working on such a platform that is called as a IoT, that Internet of Things. Again, that was coming in the engineering, and that too is called as a smart grid. The smart grid is going to be communicate with the machines and with the human interface system or human interface. system, is it? Then once we are going to discuss about the smart grid, then we have another good topic for that, which I taken in the in line with our FDP topic, that is called as different types of grid integration. Grid integration into what is uh, there presently, the government is giving some kind of promotion, we can say, or some kind of task to the state electricity boards, that they need to motivate the people, or motivate the society to install the solar photovoltaic on the rooftop. So this then when it whether it's for the residential sector, whether it's for a commercial sector, or the and at large is the industrial sector. So what kind of grid connections would be possible till that what was there in a electrical installation with the solar photovoltaic? I'm not going to make it hybrid. Okay, so it's only for a solar photovoltaic. Uh, then important to know about this modeling and the performance forecasting using some MATLAB tools. And then I have other presentation on the energy storage, hybrid system, and then some references what we I have used, and then question and answers. Is it okay? So the flow, yes. Oh, I think Gosal sir is only interacting with the. Okay, 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 okay. Thank you, madam. Yeah. So, but it's not possible to check me. I need to exit and check. Okay. So, yeah, very nice to see that we are going to talk about some solar PV system. So what could be, because those these things we studied in the 10th, up to 10th class, up to in the 12th. Okay, what is in that is a solar cell. Basically, it is a solid state electrical device, like in a electrical, prior to that, because I'm not completing that sentence, because that will be what that I'm going to read it from the PPT, so it's not looking good. So what does it, because when we say the battery was there, or in that case it the cell word is there. Okay, and the cell, what does it do is converts the chemical energy into the usable electrical energy. That was this. So here, what was to the solar cell? It is a solid state electricity device that converts the energy of the directly, which was right light is on that. Okay, who is going to give that light? The daytime, the in a globe, the one thing is available, that is called as a, that is known as sun. So sun is going to be given light, particularly uh, sending its light on the panel, we can say, on the cell, and then we can get the that to be in the form of electricity by a photovoltaic effect. Is it? So do I think all of you might have studied or somehow have a different views about that. This is what basically some is in a, I told in case of a battery, it's a chemical phenomena into the electrical. But here it's a physical and chemical phenomena, okay, which is used in the form of conversion of the energy from one form to the another form. So which is electrical energy. So while because why I'm given basically this slide, I purposely I added this because so many things are there on the solar rooftop system or grid integration, or we can say the electricity generation. Those also, but don't still if I'm going to ask the any faculty, so what are the different types of cells? Solar cells, okay, then there will be kind of question mark on their face. So that's why this I have purposely given in the first slide. So this was amorphous silicon solar cell, then bihybrid solar cell, cadmium telluride solar cells. So these are solar cells which was particularly doing this effect. Then in a second, second types of that cells, I have purposely written as a solar engines. So what does of that? What does it mean of the solar engines? Which is a kind of device or kind of system uh, which converts that particularly solar heat to its produce of motion. Also, it refers to the circuit that stores energy from solar cells into a capacitor and releases it into the pulses to animate particularly require or devices or any kind of device. You can take example of tiles. So you will observe that this kind of so when we are going to talk about the solar PV system, that is photovoltaic system, then uh, these three are one of the what we can say in our faculty's discussions. Okay, so what are the types of or when the faculty used to tell the student, so this was the first one is a crystalline silicon cell solar cells, second one is a thin film solar cells, and another one is a emerging solar cells. So what was again is there are subtypes of that, and that because it's named as a first generation, second generation, third generation, and I want to tell here that so there is a research. So there is research. Means what you will these are the means what these are not new words to us or new any particularly things to us. So these are known to us. So that is the first under the first generation monocrystalline, polycrystalline. When I want to talk about the thin film, which was there in the rooftop system, so cadmium, then CIGS, then amorphous silicon, and which was third generation synthesized, then organics, then quantum dot. So these are the. So I'll show the picture of that. So of how this compositions are there. So monocrystalline silicon solar cells, which basically is N type of silicon and P types of silicons with it have a junction, just like a PN junction diode. Is it? Then in a polycrystalline silicon solar cell, if you observe that, I think this is visible to all of you very clearly. Yeah. Yeah, and so the flow was good or means whether it's a yeah, yeah. So polycrystalline silicon solar cell, what this is? These pictures I purposely showing to you because these were there in a. If you're going to say this to the first year student, draw the figure of that. Once they're coming from the 12, they will draw it very fastly because they grab it into their 12th standard. So this what we need to particularly ask to the student in their activities. So do this and what kind of if there is a if they want to purchase the material whether they can able to do itself in the lab. So this will be one of the we can say teacher can do with the so because so innovation will become by the research. Okay. Okay, so what we need is also, particularly what we need to involve the student for the innovation. So this what we I want to say that keep the competition between the student or keep the kind like a quizzes or you can say the role play for the students so that student will be actively involved in a sector. So now, okay, although this is a monocrystalline cadmium telluride solar cells, polycrystalline is there, copper, indium, gallium, selenium solar cells are there. Okay, so all this we are discussing. My next was this one. Are, sir, you are a pretty resource person and you are asking us question. Okay, so don't say like that. What type of solar PV model used in a report of the system? Because I have shown you different types over here. Okay, okay. So this I am giving the picture to all of you. Again, showing the these two PPTs. So what will be your answer? Any faculty? Yes, I'll give 1 minute, all of you. Sir, they can unmute and or say, or they are writing in a chat box. Yeah, yeah. Yes, 30 seconds is over. Yes, fastly. Crystalline. Okay. Okay, Geeta madam, thank you. Any other participant of faculty? Dear faculty, I want to show, I want to your involvement. It is not that I'm going to tell something from the what I can AI, artificial intelligence, or okay. Your anyone you have written? So can we move further? Okay. Uh, Purposely I asked this question over here. Okay, let me say that. Okay, so don't read the left word. Okay, because these 10 companies. Okay, I given the company's name for that. So what I want to say that we need to involve the student in such a way that although they are telling the that my madam have given the one answer that it may be crystalline. Okay, so but okay, so answer is right. Okay, but which companies are involved for manufacturing of the solar power? If we give the both the uh, in together, what will happen now? They will grasp the things very fastly. So that's why I'm given this all 10 companies name. Solar Vikram Solar, which was a earlier good name, and another was a Wari, which was from the Aditya group. Another is another group was that which was have a good efficiency. Now here, although I have given the 10 names to what was when you're going to thinking about the sir, which panel is which manufacturing company is good. So then I can say that you have to see the comparison table between the solar PV manufacturers. So for that you need to think efficiency. So till date, how much is the maximum efficiency of any solar panel, or which is of 300 or to 350 watt? Anyone maximum efficiency? It means what do you thinking? It would be more than 90%, or it may be less than the 90%, or it may be it is some about around about the 50 to 70%, or it may be less than the start 50%. Anyone have given the answers? Sir? Less than 50. Yeah. Okay, very good. So I'll again add it, sir, in that till date, no panel is more than 30% efficiency. So this is a challenging to all of the engineering students, where they can make that improve the efficiency by using some different concepts of modules for making a solar cell. Okay, so that was the thing. So till date, no one have given the efficiency more than the 30%. So till now, is it the session is interesting, or I'm making it boring to all of you? Yeah. Okay. No, see, once we are going to see these are some manufacturers or these they are using these materials, okay, of the what we discussed the types. Now, which parameter, which will be say that what Bugade sir says the efficiency, and that's why I given the one characteristics. Okay, that is irradiance of PV array performance based on temperature. Okay, so these okay, what was we expecting from any cell is a output voltage, and when you're going to talk about the output voltage, okay, so even you can we can say about our the mobile batteries. Okay, nickel cadmium battery was there, and what was the voltage for that? And if we go for the higher size, then what will be the voltage? So the voltage is particularly a term, or we can say the parameters which is playing a vital role in electricity. for electrical engineers in the appliances. When I'm going to say the domestic appliances or whether it's industrial appliances, lighting load or industrial load. So that all is so. From this figure, what is your conclusion is that if you go for a higher capacity, particularly, then you will get the power output depends upon the temperature, and that's why there is one particularly buzz word was there. So at this particular point where my this cursor is moving, there is one device, it's called as a, anyone, ये करने के लिए कौन सा डिवाइस यूज करते हैं, इसको हमें पिक करना है या क्या ग्रैब करना है, क्या यूज करते हैं, विच डिवाइस इज यूज, इसके लिए ये देखो हमारा एपीसी आप लोगों ट्रांसफार्मर का दिस कैरेक्टरिस्टिक्स यू नो, ओके, particularly output power versus load current, okay, and then we used to calculate the maximum efficiency of the transformer. At that maximum efficiency condition, what was there? Copper losses is equal to what? Iron losses, okay, and then we used to calculate. So this is the maximum voltage point, okay. So this we can say in our electrical language is Vmax. So output is DC or AC? It's a DC. Okay. So therefore, the one device is used to grab this is called known as MPPT. That is called as a maximum power point tracker. Okay. So up till we are discussing about the what is a solar cell and how their performance will be uh, based on. Next, I'm going to move to the because this whatever the solar photovoltaic generation of the electricity is used in the existing grid, is it? And that existing grid, or we can say that is utility, okay, then that we are going to say it is a our grid is there, which is a power grid, and then we are how to make it a smart grid. Then why to not go for what is a basically smart grid, okay. Okay, so what that smart grid, okay, which was includes automation, which was a systems of a systems with a power and energy layer, with communication layer, and IT and computer layer. Earlier it was not there. Okay, so what I want to say, it was whether it was there with the system or not. So what does the traditional grid and smart grid, how you can differentiate, or you can say someone what does, because the electrical network is switching towards the smart. What? Yes, yes, sir. Any question? Any doubt? Yeah, yeah. Thank you. Thank you. No, no, MATLAB is still I have not covered, but MATLAB is what? So I have covered only basic of solar cell, and because grid integration is coming, and that grid integration we are going to say it is a smart grid. So that's why I included smart grid first, and then we'll switch to the MATLAB. So this was what my thought process. Okay, so traditional and smart grid is means what where then there was a kind of we can make the comparison by showing the pictures to the students, or what is that basically a centralized generation and what is a distributed generation. In this case of centralized generation, you can give the examples of our existing power plants where thermal power plant was there, hydropower plant was there. So these are centralized, okay, which are far away from the particularly urban areas. Okay, that must be well discussion. And distribution is, generation is a local generation. Okay, so which in particularly includes renewable energy sources. Is it? So another is was that what we were expecting is a reliability in case of the electricity. So that was more in case of a smart grid. So in this way you need to. So when you are thinking about the smart grid, so this picture is going to cover all the things where electrical vehicle. Then, I mean, sir, our left side, if you're going to see this renewable energy sources, then electrical vehicles was there. Then smart cities, these buildings are there. Smart houses are going to come. Even solar photovoltaic plants are there. Then thermal and factories. So when you are going to say that what was the smart grid, it consists systems of systems. So see here, this one system existing was there, and then you are adding subsystems some in that, which was some advanced system with some intelligent electronics devices, IED it's called, is it? This is what a smart grid. So what the traditional grid have a one directional flow, and that's why it need to be switched towards the we can say the to the smart grid. Okay, so where there will be a two-way communication. So what does it mean a two-way communication? At the consumer side, the consumer will generate the electricity through advanced electrical generation techniques or technologies, and they can once they are going to use, if they are generating the surplus energy, they can integrate it to the grid, and they can directly feed it to the grid. So that's why it's called as a two-way of electricity and information. Is it? I think it's right or wrong. Okay, so anyone have a more than this definition for a two-way flow of electricity? Anyone? Yes. Yes, sir. Participant. Yes, anyone have more than that? So, when we're going to see this concept, how this evolution of particularly smart grid comes in the picture. So, where advanced technologies that make the availability of smarter, more efficient electrical power grid, there will be. So, therefore, what industry needs? So, they need some holistic approach uh, when the grid is so particularly solving some problems. Then commit sustainability and support technology advancement with some policies that facilitate technology implementation. Basically, if you're going to say, because what that evolution is consists where micro generation, then loads and appliances, energy efficiency. This I got from, see this slide, basically I got from the side of NTPI. So national, what is NTPI? Anyone? Yes, National Training Power Institute, which was there in a globe. So there are some attributes which are there for this particular eight attributes are considered. First one is information based. Second one is direct, particularly that grid should be communicating. Yeah, important is security, then self-healing, reliable, flexible, co-effective, dynamically controllable. So we are going to talk about more on the what is self-healing. So what way then does the existing grid is not smart grid? Is yes, not a smart grid. Okay, where there is a something was there, something what particularly in that existing grid. So that's why the word is used smart grid, which particularly stopping power theft, high quality, reliability of power. There will be a fewer blackouts for the electricity, which will be when growth justifies the cost. We are going to integrate the renewable energy system. Then what we are today facing the problem of global warming. Okay, where our particularly a slogan of FDP was there. So negative image, negative effect of image emission, then utility operation, and poor access to the electricity in a rural area. So you means that, so those are from the rural background. Okay, so they know what they are facing nowadays. Somewhat because of this advancements in the technology, and there was a renewable energy generation. Okay, so the rural area is nowadays, I'm not telling that they are not facing that much blackouts over there, or that much, not a blackouts, we can say shutdown of the electricity. Is it? So when okay, so I'll moving instead of that because see here when we are thinking when system to be converted to as a smart grid, so then there is some opportunity. So in which area that opportunity will be there? In two areas I want to say. One is a electricity where we are going to supply side. Okay, is it? And another is the demand. Is it? So what was when here supply side opportunities, advanced transmission system. Yeah, important is the energy storage. One of our topic was that increased use of solar technologies and yes, microgrids, smart grids, and network optimization. So many papers. I'll say that the faculties, all the faculties, you will get thousands of papers particularly from year 2012 to till date on this particularly topic. Okay, so and then you can find the gap between that papers and you can go for the research. Another is what is the demand side opportunities. Yes, now that yeah, I think you might have heard in 5 or 6 years before that the government of India has taken initiative for the smart cities. And once you go to the smart cities, the energy which is going to be supplied is need to be by a smart energy meters or smart technologies we can say. Then metering infrastructure will be there. The investor opportunities and what was the basically government is giving the support to the smart grid. Even a budget every year financial budget government is giving funds for this particularly initiative. Basically, what are the different functions of a smart grid? Exchange data on the electricity generations, consumers, and grids. Integrate numerous new smaller electricity generation facilities. Balance out fluctuation in electricity. Existing and planned implementation of smart grids by smarter way, and means because we are talking about the demand management, so what obvious load management is or load adjustment is going to come, and therefore the through this cloud it would be possible that demand response support. Okay, so that is called as a forecasting and particularly planning and execution of that electricity network for the next day. Is it? So I think another so, means so these are also some functions where it can resist the attacks, motivate consumers to actively participate in a operation of the grid. How? By particularly installing the solar photovoltaic on the rooftop. Then provide high quality power, optimize assets what they have in a system. Then we can accommodate the generation options. I have given some equations for that in the next few slides for that how you can accommodate generation options and storage options that particularly in case of the electricity. So what does word self-healing is says it is a kind of particularly reconfigure the distribution network to minimize the consumers impacted or minimize the electricity interruption. Uh, Control system that analyze its performance using a distributed controller. Uh, Also it consists what is because self healing what does it is going to consider, so okay, or which parameters are there in a self healing, that is automation which is through this PCs, and then we have circuit breaker parallel generators, and then this particularly circuit breakers which will be brought back in the online mode. So what this NPTI says about the self-healing? So is using a real-time information from embedded sensors, that is what we are going to say is IoT, and automated controls to anticipate, detect, and respond to the system problems. A smart grid can automatically avoid to mitigate power outages, power quality problems, and service disruption. So I think all of you, if you want to note down this one, this particularly uh, sentence for telling the upcoming generation, which was which are taking admission for the engineering colleges. So that what again self-healing in a smart grid is there will be fault circuit indicators, transformer monitors, then voltage regulators, then reclosers are there, then distribution automation, automatic power factor corrections, then communication networks. So these all are going to work in a particularly smarter way so that we'll get the lesser blackout and quality power to the consumers. Is it? So there is one again concept of a resilient in a smart grid. It is a property of that grid. Okay, so which has have multi-transmission. So it requires managing disturbances, organizing from physical components failure, cyber components malfunctionings, and human attacks. So this is what resilience in case of a smart grid. A more resilient grid is a more reliable grid. So it have a flexible and survivability concept in case of. So what I have a drawn me. So this is my